In this recording, we are going to discuss number 12, how to measure correlation using Spearman's coefficient of rank. Okay. So it says an educator is interested in the correlation between the level of academic motivation and a student's mathematics score. So that's the title, level of academic motivation and mathematics score. So the objective now is to analyze the correlation between, okay, that's supposed to be academic motivation and mathematics score. Of the population of students. Right. Now, here's how this was done. The title is Academic Motivation Mathematics Score. The research question is, what is the correlation between academic motivation and mathematics score? And the hypothesis is that there is a weak positive correlation between academic motivation and mathematics score. All right. So to measure that correlation now, Spearman's rank correlation was used. Here's the formula. This is the Greek R for relationship, and it's called rho, is equal to 1 minus 6 times the sum of d squared over n times n squared minus 1 in a bracket. Now, this was taken from weekly notes number 7. Let's check it out. Here we are in weekly notes number 7. It says measures of correlation. The coefficient of correlation gives a measure of the degree that two variables are related to each other. This value cannot be less than -1 and cannot exceed the value of 1. The following is a scale of values of coefficient of correlation. So it's from -1 to 1. Between -1 and -0.5, you have a strong negative. By the way, -1 is a perfect negative, and a positive one is a perfect positive. So you have strong negative, and then you have weak negative between -0.5 and 0. You have weak positive between 0 and 0.5, and you have strong positive between 0.5 and 1. And here are the steps for the Spearman's coefficient of rank correlation, symbolized rho. This method of measuring correlation is relatively simple compared to the product moment. So there's another method called product moment, which we'll be discussing in another video. So first you have to create 2 more rows or columns and label one rank X and label one the other rank Y. Okay, so let's see where this was done. Right, rank X and rank Y. The highest value is given a rank of 1, the second highest a rank of 2, and so on. Okay, so as you can see, when you rank in the X is the academic motivation, is the independent variable. The highest value there is 5, so 5 was given a rank of 1. There are 2 5s, so there are 2 ranks of 1. 4 is the second highest, 4 got a rank of 2. And there's another 4, so both get a rank of 2. 3 coincidentally got a rank of 3. There are 3 3s coincidentally, so each one get a rank of 3. And 2 is the 4th highest, get a rank of 4. And 5 is the smallest, it got a rank of 5. Now you have to repeat the same now for the Y values, which is the score. 95 is the greatest, so it gets a rank of 1. There are 2 95s, so each will get a rank of 1. And then 90, well, there are 3 95, sorry. And there's a 90 got a rank of 2. 66 got a rank of 3. 60 a rank of 4. 54 rank of 5. 44 rank of 6, and 43 rank of 7. Now, the D squared now is the rank X minus rank Y, open close bracket, squared. So it's the difference between the rank squared, D for difference. So 5 minus 1 is a -1. But when you square -1, you get 1. 5 minus 7 is -2. -2 squared is 4. 2 minus 1 is 1. 1 squared is 1. 4 minus 5, negative 1 squared, 1. 3 minus 4, negative 1 squared, 1. 3 minus 3, 0. 0 squared is 0. 1 minus 1, 2 minus 2, the same. 3 minus 5 will give us 2, negative 2. Negative 2 squared is 4. And 1 minus 1 is 0. 0 squared is 0. Now, as the steps say, after you have calculated all the squares of the differences of the rank, all these values are then the sum of the values are found. So after you find the squares, you add them up, and the value of this squared is then inserted into the formula. Here it is, the sum of this squared. And here's an example. You can check it out. But let's go back to our example. So the d squares were summed up, get a value of 12. 1 plus 4 is 5, plus 3, 8, and 4, 12. So the 12 was placed into the formula, where the sum of this squared is. The formula comes with a 6, and n now is the number of pairs. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs. Okay, so n is 10. And as you can see, 10 squared is 100 minus 1 is 9. 99, sorry, 99 times 10 is 990. And then 6 times 12 is 72. 72 divided by 12 is 0.072. And then finally, you subtract 1. 1 minus 0.072 will give us a value of 0.93. So according to Spearman's ranking, the correlation is 0.93, which is a strong positive. Okay, so that's how you calculate Spearman's rank. And you can follow this example also, example 7.1. Okay.